Okay, so I got cut off in the last video there. I'm going to be a little quicker. Just was talking about the different wavelengths of infrared. It basically allows you then to see which parts are hotter and which parts are cooler. So that's known as a thermal scan of your house. It tells you what parts of your house then are leaking heat, windows, doors, bad insulation on the roof, that kind of a thing, and that's it. So one of the demonstrations that I actually didn't do with you guys was to detect infrared and ultraviolet. So the setup goes like this. You have a prism and that produces a spectrum, and you put a thermometer just at the red end, just past the visible red end. It should be a thermometer with a blackened bulb, so that absorbs the infrared, and what you should see is the thermometer starting to rise in temperature. So that shows you then that even though there isn't any visible light on it, there is the infrared light, and it's causing the heating of the thermometer. The other side then to detect ultraviolet, Vaseline actually is a very good thing, that it glows. So if you hold something with a little bit of Vaseline on it, just past the visible purple end, what you'll see is that glows, and that shows that you have ultraviolet at that end. Now, it's a very simple demonstration, and that is literally it. It does both of those. The primary and secondary colors. Now, I have a lot of questions there, but this, I suppose, a lot of this comes from Junior Cert in how do we see colors. So if I have an object that is red, why is it red? So if we have, I'm going to do this here, if we have white light that comes in and I have a red object, it's great art here. The reason we see it as red is that it absorbs all the colors except for red. So red objects only reflect the red part of the light that hits them. So if we have a filter, and if we're looking at objects, how a filter works is something similar in that a red filter only allows red light to pass through it. So you can have white light hitting that filter, and it appears that the filter is making red light, but actually it's absorbing all the colors except red, and it's allowing red through. Blue filter works exactly the same. It absorbs all colors except for blue. And let's say we had a cyan filter. Well, a cyan filter basically is going to absorb red, and it's going to allow blue and green through. So filters work by absorbing every color except the filter color, if you know what I mean. So a blue filter, it absorbs everything but blue. A red filter absorbs everything but red. Now, that kind of knowledge, they only really tap into at higher level, but when this stuff that I went through up here, they are assuming you know that from kind of Junior Cert. So why does an object appear? Why does a blue object appear blue? That's expected at Leaving Cert. You are then talking about your primary colors, red, blue and green, and the mixing of those primary colors to give you secondary colors. So cyan, magenta, and yellow. You do need to know what colors give you, so that, for instance, blue and green give you cyan. You do need to know that. And at the higher end of that knowledge then is if you shine a primary color. So let's suppose that you shine a red light, for instance, and you shine it onto something that is cyan. Well, a cyan object is going to reflect only blue light and green light. So it'll absorb everything else. Okay? If you shine red light onto something that absorbs red light, it's going to appear as black. So that's how you work that out. If you are shining a green light onto a magenta object, well, think about what colors make up magenta? What are the primary colors that make up magenta? If an object appears magenta, it means that it is giving off those two colors. And if I shine red on it, is red one of those colors? If it is, then it will appear red. If it's not, it will appear black. Now, I have videos that I will put the links up because there's no point in just showing you those there, but that go through that. Now, again, that's very much at the higher end of higher level. So those questions would pretty much cover what you need to know when it comes to primary and secondary colors. So you can pause the video and have a look at those. And that's pretty much it then for the chapter on light. The experiment, again, that's quite important. Outside of this, I'm not going to go through it here, but the wave nature of light being different than the optics light that we dealt with in the previous chapter when we were talking about lenses and all that. Okay, that's great. Thank you very much, gentlemen.